Okay, welcome to a video on the rhombus. I know the title says rhombi and squares. Rhombi is plural for rhombus. This video is going to cover the rhombus page and properties. The first thing we talk about is all rhombi have all the properties of a parallelogram, which also has all the properties of a quadrilateral. Very quickly looking at our flow chart, we start with this quadrilateral, the two properties it has. We move down to a parallelogram, we add 5 more properties to it. Then we branch over here to the rhombus, and we're going to add 3 more properties. So this 2 plus the 5 giving us 7, and then adding the 3 giving us 10 total properties. Okay, we don't focus on these rectangle properties. Those are not properties of the rhombus. So here, everything this rhombus is under has all of those properties. So with number 2 here, we'll go ahead and label on here this first shape right here, this first rhombus. We have all sides are congruent. So this is the first parallelogram we talked about with the all sides are going to be congruent. The next one down here, your diagonals, we've got a little bit of property of the diagonals. The diagonals will bisect each other because that is what it's under the parallelogram properties. But the diagonals are also going to be perpendicular to each other. We need to remember this means 90 degrees. It's going to form a right angle. So when we have our diagonals in here, we are going to have a right angle at the intersection. And what you're also going to need to identify with this is we're going to end up with a right triangle in here as well. We will be using that. So right here, you can use Pythagorean theorem to find different parts because we have that right triangle. Next, we also have another diagonal property. The diagonals are also going to be angle bisectors. So if we draw in this first diagonal, it's going to bisect this angle over here. And because parallelograms opposite angles are congruent, we just put one arc over here as well. All 4 of these little angles will be congruent. We draw in the the second diagonal, and we do have to put 2 arcs on this one because they're not congruent to the first ones. So here we go, bisecting, and again, these opposite angles will be congruent. So we'll put 2 arcs over here also. Now we take a look here, number 1, right off the bat, we've got 4 different angle measurements that we're going to find. In rhombus ABCD, the measurement angle BAC is 32 degrees right here. They went ahead and gave that to us, BAC, just this little part. We want to find the measurements of all of these. Well, to find the measurement of angle 1, this is where, just what I told you, we're going to have to use our Pythagorean theorem because we have this right triangle. So we want to make sure that we draw in here our 90 degrees, not Pythagorean theorem, I'm sorry, triangle sum theorem. All apologies. So the measurement of angle 1, we're going to use that not only are the diagonals perpendicular, but we're going to use your triangle sum. Here we have our 32 plus our 90. We wind up with 122. Then we subtract it from 180, and we find that this will be, in measurement of angle 1 is going to be 58 degrees. Now we look at the measurement of angle 2. Right over here, well, we just found out that the measurement of angle 1 is going to be 58 degrees. Well, because let's go ahead and write in here, measurement angle 2, the diagonals bisect the angles. That means that the measure of angle 1 is congruent to is the same. Angle 1 and angle 2 are congruent, so their measurements are the same. We'll go ahead and write that in. Measurement of angle 1 is equal to the measurement of angle 2. So the measurement of angle 2 is also 58 degrees. The measurement of angle 3. How are we going to find this one? All right, looks like that pen's not going to last. The measurement of angle 3, we know that our opposite sides, 3 is over here. We're going to know that with our parallelogram properties, our opposite sides are parallel. So we're going to bring in here parallel lines and a transversal. If Segment DC and segment AB are parallel. We can look at it as here are parallel lines. And then segment AC is going to be our transversal, telling us that the measurement of angle 3 is alternate interior with the angle BAE. So these two will be congruent. Go ahead and add in a second arc though, because we already have congruency marks here. So you have your alternate interior angles. Add in. This will be 32. Then to finish this off, the measurement of angle 4. Your diags are perpendicular. So measured angle 4 is simply, we wrote that in at the very beginning, is simply going to be at 90 degrees. All right, number 2. We're told here that the length of AE right here is 8. We want to find the length of AC, the whole entire diagonal. We only have part of the diagonal. Well, one of our properties here is going to be that the diagonals are bisected. They are cut in half. So what that means right here is the length of AE is equal to the length of EC. So that means EC is also 8. Then all we have to do is combine those together. Get that entire diagonal. Number 3, we are seeing here that AE right here is 3x plus 1. Minus 1. And that AC, the entire diagonal, is 16. We want to find x. Well, in this case, we're going to use, because again, our diagonals are bisected, we're going to use a part plus part equals whole. Remembering that both of our parts are the same, so that means EC will also be 3x minus 1. So part 3x minus 1 plus the other part 3x minus 1, all equal to 16. We're going to go ahead and combine our like terms to get 6x minus 2 equals 16. Add the 2 to both sides. 6x will equal 18. Then when we divide, didn't really leave myself a lot of room, apologize about that. We're going to find out that x is 3. All right, number 4. On number 4, we are looking at if the measure of angle ABD, so right here at ABD, we have 60 degrees. We want to find the measure of angle BDC, so BDC. Again, we're going to use the property that our opposite sides are parallel. And this is going to give us, again, your alternate interior angles. There's our parallel. So we have 60 degrees. Sorry, this is supposed to be angle symbol apostrophe S. Last for the rhombus notes. If the measure of angle CDB, so from C to D to B, is 6y, and the measure of angle ACB, from A to C to B, is 2y plus 10, we want to find y. These two angles are not congruent, okay? But again, because we're going to use our property of the diagonals, the diags, bisect the angles, we can say that angle BCA right here will be congruent to angle DCA, meaning this is also going to be 2y plus 10. Then we can use our property of the diagonals are perpendicular. And then go into triangle sum theorem, everybody's favorite, right? So we're going to take all three of these angles, just focusing on triangle CED right here. We've got your 2y plus 10 plus 6y plus the 90, all equal to 180 degrees. We'll combine our like terms. Oops. Giving us a total of 8y plus 100 equals 180. And then we take our two steps, subtract the 100, and then divide. And y ends up being 10. So a lot more properties coming in. I'm pretty sure we covered all of them, the diagonals being perpendicular. We did not cover the all four sides are congruent on this, but don't forget about that property as well.